Like add, remove can be performed from the front or the end of the list. Let's take a look at an example using the list of values 3, 5, and 7. Removing the tail node, 7, requires updating the tail pointer and setting the next value for 5 to null. Doing that will eliminate all references to the 7 node, which effectively removes it from the list. Now this is conceptually very simple. Let's take a look at how the list is going to look after this is done. Now we can see that the 7 node is gone, the tail pointer points to the 5 node, and the 5 node's next is equal to null. This is what we wanted. But you can see from the code that this requires enumerating over all of the nodes in the list. This is because we're only storing references to the head and tail nodes. But to perform this operation, we actually need to update the second to last node. Now this is not incredibly complex. It's a simple while loop to iterate until the second to last node. But having to walk the list every time a node is removed from the end can end up having significant performance implications on your application. Imagine a list that contained millions of nodes. Removing each node from the end could require millions of operations. So removing from the front of the list is not nearly as complex. It simply involves setting the head pointer to the node that follows head, and that's it. When the list contains only one node, removing it involves just setting head and tail to null.